Hello, myself Vedan Shankar Surenshi of Robotics and Automation branch from R1 batch. My PRN number is 2471090024. Now I am going to solve an differential equation using of the which is convertible into linear differential equation. So let's get started into it. We know that for the equation to convert in LDE, it must be in the form of f dash y into dy by dx plus f of y into q is equal to p. In this case, like we have seen, where f dash of y and f of y are functions of y only, and p and q are functions of x only. So in the by comparing this to above equation, we can see that there is a cos square y term in the right hand side, which must not be there, because there are only x terms consisting of x is required. So we will divide the equation, uh, dividing the equation by cos square y, we will get 1 upon cos square y dy by dx plus x into sin 2y upon cos square y is equal to x cube. So we can also write it as uh, secant square y into dy by dx plus x into, we can write sin to x as 2 times so sin y into cos y upon cos square y is equal to x cube. By simplifying this, we will get secant square y dy by dx plus uh, 2x sin y upon, we will get here sin y upon cos y. After cos square and cos square will get cancelled, then we will in total get tan y is equal to x cube. Now by, we will give equation 1 by comparing with, we will now compare it with the standard form, that is f dash of y into dy by dx plus f of y into p is equal to q. What we are getting is f of y is equal to tan y, and f dash of y is equal to secant square y. Also p is equal to 2x and q is equal to x cube. Hence if uh, hence if we put tan of y is equal to v, then we can say that uh, by taking derivative on both sides, taking derivative with respect to x on both sides, we will get secant square y dy by dx is equal to dv by dx. Now we just have to modify the given. Now put the this value, like here we will give equation 2 and 3. Now we can say that using equation 1, 2 and 3, that using equation 1, 2 and 3, we can replace secant square y dy by dx by dv by dx, like given here, and tan y using v. So we will write that dv by dx plus 2 times xv is equal to x cube. So it is LDE, which is linear differential equation in V. So in this case we have P is equal to 2x and Q is equal to x cube, which were earlier derived. So but the integrating factor if is equal to e raised to integration of p e raised to integration of p dx. So it is here integration of 2x dx. We know that integration of 2x is x square, so it is e raised to x square. Hence integrating factor is e raised to x square. So solution of this equation will be given as solution will be given by v into integrating factor is equal to integration of q into integrating factor with respect to dx and overall addition of constant. So by replacing v, we can write v as tan of y into integrating factor our e raised to x square is equal to integration of, we know that q is x cube into e raised to x square dx plus c is our uh, required solution. So here now we will solve the integration for the solution, which was tangent of y into e raised to x square is equal to integration of x cube e raised to x square dx plus c. We can write the above equation as tangent of y into e raised to x square is equal to x square into e raised to x square into x dx integration sign and plus c. So for simplification we will put x square is equal to t, then we will say 2x dx is equal to dt. Therefore overall value of ax dx is equal to dt divided by 2. So after all the substitution we will get as tan y into e raised to t is equal to integration of t into e raised to t dt divided by 2 plus constant. So we will first shift this divided by 2 into this side, that is tan y into e raised to t, then the remaining integration will be t into e raised to t dt plus c as the constant of integration. So now we will solve the this integral using the by parts, and for this we will know that arithmetic equation is taken as the first and the exponential is the last one, so we will consider it as the second equation. So using by parts we know that first as it is the integration of second function minus integration derivative of first into into second function e raised to t and the overall integration with respect to dt plus we have the constant of integration as it is. So after further solving it we will come to know that e into e, we know that integration of e raised to t is e raised to t minus minus integration of e raised to t dt plus c. It can be given as t into e raised to t minus e raised to t plus c. By taking e raised to t common we will get as t minus 1 plus c. So 2 tangent of y into e raised to t is this. Now putting all the values back, we will get 2 times tangent y into e raised to x square is equal to e raised to x square into t. Now we have t x square minus 1 plus c. So this is our final answer. As we can see now, we can further modify the given equation by dividing by 2 or something, but this is a form of the solution. This is our required solution, in which first we have taken an equation, then converted it into the standard form, then by identifying fy and f dash of y converted it in LDE. So this is the LDA by putting value tan y is equal to v. We have converted it into a LDE in v, and then solve the equation and then finally put all the values, and after doing that we have got the final answer. So this is it. Thank you.